Hi students, welcome to today's class. So today also I am going to explain various important topics from the chapter pair of straight lines. Okay now. So without wasting your valuable time, so let us start our class. So observe these two figures. Here you have a two set of pair of straight lines. In the first set, this pair of lines passes through origin. These two lines are passing through origin. You know that the equation of the pair of lines is these two ax square plus 2hxy plus by square is equal to 0. The equation of the pair of lines. See these red colored lines, they also passing through the origin. But these two lines are perpendicular to the lines ax square plus 2hxy plus by square is equal to 0. So the first line is perpendicular to here the first line, here second line is perpendicular to the second line. So but both are passing through the same point of intersection is same for both the set of pair of lines. Now what will be the equation of these lines? So the equation of pair of lines passing through origin and perpendicular to the pair of lines ax square plus 2hxy plus by square is given by, so just interchange the coefficients of x square and y square, that is equal to, so this is a bx square plus ay square is equal to 0. Here xy coefficient is there, no, plus 2h. What is the sign here? Plus. If it is a plus, you write down minus. If it is a minus, you write down plus. So this is equal to minus 2hxy. So this is the equation of the pair of lines passing through the origin and perpendicular to the pair of lines ax square plus 2hxy plus by square is equal to 0. Right. Just how to remember, interchange both a and b. In the center, if it is a plus is there, put minus. If it is a minus is there, put plus. Okay now. But here you see here, the equation of this pair of lines is combined equation is ax square plus 2hxy plus by square is equal to 0. Ax square plus 2hxy plus by square is equal to 0. But here also these two lines are perpendicular to the lines, but they are not passing through the origin. They are intersecting somewhere, that is a x1 comma y1. They are intersecting somewhere at x1 comma y1. Okay now. Then what is the equation of this pair of lines? What is the equation of this pair of lines is given by same, almost same, but in place of x, you will get x minus x1. In place of y, you will get y minus y1. So this is equal to b into x minus x1 whole square minus 2 times x minus x1 y minus y1 plus a into y minus y1 whole square is equal to 0. In place of x, substitute x minus x1. In place of y, substitute y minus y1. That's all. Almost both formulas are same. But here the pair of lines passes through the origin. But here the pair of lines are not passing through origin. They are intersecting somewhere at x1 comma y1. But these two lines are perpendicular to the given lines, that is ax square plus 2hxy plus by square is equal to 0. Okay now. So next what we are going to see is now, so if these any two lines, if there are any two lines parallel to these lines, and they are passing through x1 comma y1, that means the first line is parallel to the given line and the second line is parallel to this line. Okay now. Then what will be the equation of the pair of lines? So this is given by same equation will come, but in place of x, you will get x minus x1. In place of y, you will get y minus y1. So your equation a into x minus x1 whole square plus 2h into x minus x1 into y minus y1 plus b into y minus y1 whole square is equal to 0. So these two lines are perpendicular. This is the equation. These two lines are parallel to the lines given by the equation ax square plus 2hxy plus by square is equal to 0. Okay now. So same coefficients you will get a, 2h, b. But the only difference is in place of x, you will get x minus x1. In place of y, you will get y minus y1. Okay, now, right. I hope that you understand this concept. So, let us go for next concept. So, dear students, here so far we have seen the equations of all the pair of lines passing through the origin. All the equations, all the lines are passing through origin and the angle between them, what are the conditions, everything we discussed. What are the perpendicular condition, parallel coincidence condition, angle between them, pair of angle bisectors, all those things we learn. Now, let us see the equation of the pair of lines which does not passes through origin. So, let us take x axis and it is y axis. Okay. So, there are two lines are there, they are not, there are two lines, they are intersecting at the point x1 comma y1. They are intersecting at the point x1 comma y1. Then what is the equation of these lines? Okay. Now, they are intersecting somewhere other than this, they are not passing through the origin. They are intersecting somewhere at, then what is the equation of this pair of lines? So, let us take this equation as x plus y some minus 3 is equal to 0, some this is x minus 2y plus 7 is equal to 0. So, these are the two equations, they are intersecting at some point x1 comma y1. So, if you want to find out the combined equation of these lines, combined equation. So, this is an individual equation of each line. So, if you want to find out the combined equation of these two pair of lines, then what you have to do? So, you have to multiply these two equations. So, you have to multiply these two equations. Then how to multiply? So, this is a combined equation is x plus y minus 3 into x minus 2y plus 7 is equal to 0. So, this is the combined equation of the pair of lines. So, if you multiply, so what you will get? So, definitely you will get x square. So, minus 2xy plus 7x plus yx minus 2y square plus 7y. So, this is a minus 3x plus 6y minus 21 is equal to 0. So, if you put it in an order, so you will get x square minus 2xy. So, this is a x square minus 2xy. So, this is minus 2. So, minus 2xy plus yxy. So, this is a minus xy. So, this is a minus 2y square. So, this is a 7x minus 3x. So, this is a 4x and 7y plus 6y. So, 13y minus 21 is equal to 0. So, this is a x square minus xy minus 2y square plus 4x plus 13y minus 21 is equal to 0. So, what is the general form of equation? What do you observe here? You are observing x square term, you are observing xy term, you are y square term, x term, y term constant. So, this is a general second degree equation in x and y variables. The general second degree equation. So, what is the, in algebra we came to know that what is the general second degree equation in x and y. So, it is given by ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So, this is the equation of the line. Generally, we call it as a s is equal to 0. So, this is the equation represents the second degree equation in x and y, represents the pair of lines. But the thing is, there are certain conditions on a, h, b, g, f, c. So, these are the real numbers. Not all second degree equations represents the pair of lines. So, depending upon the conditions A, H, B, G, F, C follows, they represents the sometimes they represents the pair of lines and sometimes they represents the ellipse, hyperbola, all the things they will represent. Now, what are the conditions? What are the conditions that to represent this second degree equation a pair of lines? Okay, na? So, let us see that. Welcome back to this concept. If ax square plus 2hxy plus by square is equal to 2gx plus 2fy plus c is equal to 0, this is called general second degree equation. General second degree equation in the variables x and y. general second degree equation in the variable x and y. So, this is general second degree equation, but all not general second degree equations represents the pair of straight lines. So, depending upon the conditions on A, H, B, G, F, C, they are what? They are real numbers. So, depending upon the condition that satisfies these, they represents the pair of straight lines. So, if delta value, so that what is this value? ABC plus 2FGH minus AF square minus BG square minus CH square is equal to 0. And those three conditions also. What are the three conditions? H square greater than or equal to AB, F square greater than or equal to BC, G square greater than or equal to AC. Then this equation represents a pair of straight lines. Okay, when you are saying pair of straight lines, there are different types of straight lines will be there. So, if you are asked to draw two lines in a plane, so first thing there may be intersecting lines you will get. So, these are all called intersecting lines. Otherwise, you may draw parallel lines. So, this is called parallel lines, intersecting lines, parallel lines. Otherwise, you can call it as a coincidence lines. So, here the two lines will be coincide. The next possibility is perpendicular lines. Next possibility is perpendicular. So, when you are asked to draw two lines in a plane, so these are the four possible cases. So, this is called intersecting lines, this is called parallel lines, these are all called coincidence lines, these are all called perpendicular lines. Now, what are the conditions to represent intersecting lines? So, to represent intersecting lines, the condition is delta I is equal to 0. That means, for this condition is what? Delta I is equal to 0 and H square strictly greater than AB. Delta means this value, ABC plus 2FGH minus AF square minus BG square minus CH square. Its value is 0 and H square is strictly greater than AB. H square is strictly greater than AB. Then those two lines are intersecting lines. If same delta is equal to 0 and H square is equal to AB and G square plus F square greater than or equal to C times A plus B, then they represents a pair of parallel lines or coincidence lines. Pair of parallel lines and coincidence lines. If A plus B is equal to 0, what is A plus B? A is x square coefficient, B is y square coefficient. If these two values, sum of those two coefficients, that means x square coefficient and y square coefficient, if the sum of those two coefficients is equal to 0, then the lines are represented by perpendicular lines. Understand? So, these are the conditions of, this is the first is what? Pair of lines. Second one is intersecting lines, next to parallel lines, next to perpendicular lines. So, these conditions you should be known very well. So, this is called having a grip over the subject. Okay, na? So, let us see the next concept. Welcome back to this concept. So, this is the area of the triangle. So, in the yesterday's class I explained the area of the triangle formed by the pair of lines ax square plus 2hxy plus by square is equal to 0 and the line Lx plus. So, this is the line Lx plus my plus n is equal to 0. So, if you want to find out the area of this triangle, so the formula is given by n square under square root of h square minus ab upon modulus of am square minus 2hlm plus bl square. Okay, na? So, this is the formula of the finding area of the triangle. Observe here, here the pair of straight lines are passing through the origin x1 comma y1. Okay. So, in the second case, here the pair of straight lines are not passing through the origin. They are not passing through origin. So, this let us take the point of intersection of the pair of lines is x1 comma y1. So, x1 comma y1 and the equation of the line is Lx plus my plus n is equal to 0. Now, if you want to find out the equation of area of this triangle, so what is the formula? So, here x1 y1 is the point of intersection of the pair of lines. Then what is the area? So, area is given by the formula Lx1 plus my1 plus n whole square by under square root of h square minus ab upon am square minus 2HLM plus BL square. Okay now. So, comparatively read this formulas. Comparatively, if you observe here, what are the similarities you are observing in the two formulas? Means the first similarity is denominators are same. So, this is am square minus 2HLM plus BL square. There am square minus 2HLM plus BL square. So, here the denominator is same. Here also the denominator is both the denominators are same. First thing that you have to observe, in the numerator, here h square under square root of h square minus ab is there. Here also under square root of h square minus ab is there. So, here also root of h square minus ab, there also root of h square minus ab. So, observe here only the difference. So, here n square is there, here lx1 plus my1 plus n whole square is there. So, very simple. So, here the point of intersection is x1 comma y1. So, if you substitute x1 is equal to 0, y1 is equal to 0, 0 comma 0, substitute here, in place of x1 put 0, in place of y1 put 0, so this whole will become 0, n square, you will get this case. So, like that. So, that means both the cases formulas are, the only difference is that in place of here, you have to put lx1 plus my1 plus n whole square. So, if it is x1 comma y1 or happens to be 0, these lines are passes through 0, here x1 y1 put 0 here, n square you will get. So, remaining all terms are same. So, here root of h square minus ab, here also root of h square n may be, denominator is also same. So, that means you learn this formula lx1 plus my1 plus n whole square. So, this will comes the general case. So, this is the main case and it will comes the general case. So, in place of x1 and y1 put 0 comma 0, you will get this case. Okay na? So, I hope that you understand this concept. So, let us go for next concept. Welcome back to this concept. So, this concept is point of intersection of the pair of lines. If the pair of lines equation is h is equal to ax square plus 2hxy plus by square is equal to 0, then this pair of lines passes through origin. Obviously, the point of intersection is 0 comma 0. That is clear, origin. Right. If the pair of equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0, then the pair of lines does not passes through origin. Their point of intersection is x1 comma y1. So, if you want to know the x1 and y1 coordinates, the formula is given by hf minus bz upon ab minus h square comma gh minus af upon ab minus h square. Here the condition is ab is not equal to h square. So, ab is not equal to h square. So, here the point of intersection is 0 comma 0. So, here the point of intersection is hf minus bz upon ab minus h square gh minus af upon ab minus h square. So, this is the point of intersection. So, whenever an equation is given which represents a pair of lines, compare that equation with this general form ax square plus 2hxy plus by square plus 2gx plus 2fy plus c. Write all the compare like coefficients, find out the a value, b value, c value, f, g, h values, and you substitute there, you will get the point of intersection. Okay na? Right. I hope that you understand this concept. So, let us go for next concept. Let us welcome back to this concept. The concept is angle between the pair of lines. So, here we know the angle between the pair of lines. If the equation of the pair of lines is ax square plus 2hxy plus by square is equal to 0. If theta, that means these two pair of lines passes through the origin. So, this pair of lines passes through the origin. Therefore, the angle between them is cos theta is equal to modulus of a plus b upon root of a minus b whole square plus 4h square. So, if you want to find out tan theta value, 2 root of h square minus ab by a plus b. Okay now, right. So, this already we know the concept in the yesterday's class I explained. Now, let us see that if the lines are not passing through the origin, then what is the equation of this line? S is equal to general form ax square plus 2hxy plus by square plus 2gx plus 2fy plus C is equal to 0. Of course, here already I explained the condition satisfies. What is the condition? Delta. Delta means ABC plus 2FGH minus AF square minus BG square minus CH square is 0. H square greater than or equal to AB, F square greater than or equal to BC, G square greater than or equal to AC. All those 4 conditions are satisfying this equation. Okay now. Now that means we know that their point of intersection is not origin. So it is something x1 comma y1. Then how to find out the angle between the two lines? So if you observe, so here up to this second degree term, see here ax square plus 2hxy plus by square. There also ax square plus 2hxy plus by square. So if you compare here cos theta, you see here a, B, H, only A value, B value, H value are getting. That means A is x square coefficient, H is xy coefficient, here B is y square coefficient. There means there is no need of any G value, F value, C value. First thing we observe here. Now the angle between those two pair of lines is same as first draw a line, for example call it as L1 and it is L2. Draw a line parallel to L1 passing through the origin. So this is L1. So those L1 and this L1 is both are parallel. Draw another line passing through this point of intersection and parallel to L2. So this is L2. So L1 is parallel to L1, here L2 is parallel. So it is obvious that anybody can say that the angle between these two lines L1 and L2 is same as the angle between these two lines L1 and L2. Both those angles are equal. So now can we take the same formulas here? Same formulas here. So why? Because here also the same equation ax square plus 2hxy plus by square. Here also ax square plus 2hxy plus by square. In this formula there is no need of any G value, F value, S value. So the same formulas apply here. So for this also the same concept, formulas cos theta, tan theta, same formulas will apply. Understand? So if either the pair of lines, either they passes through origin, either they does not passes through origin, it is does not matter. So the formula for angle, finding the angle between the two pair of lines is same. Okay na? Right. I hope that you understand this solution. So let us go for next concept. Welcome to this concept. So this concept is product of the perpendicular distances from a point upon the pair of straight lines. So let us take a pair of lines passing through the origin. Let the equation be ax square plus 2hxy plus by square is equal to 0. Let alpha comma beta be any point. They may be here, but they should not be lie on the line. If it is lies on the line, the product is 0, right? Alpha comma beta be any line. Let us draw the perpendicular from alpha comma beta to the first line and the second line. Let the product of the perpendicular distance from the point alpha comma beta upon the line is d1 and the perpendicular distance from the point alpha comma beta on the second line is d2. So if you want to know the product of the perpendicular distances, that is d1 into d2, it is given by the formula a alpha square plus 2h alpha plus b beta upon root of a minus b whole square plus 4h square. Okay now, so the thing is what you have to do now, so this alpha comma beta substitute in this equation, right side or left side of this equation, a alpha square plus 2h alpha plus b beta square. Denominator root of a minus b whole square plus 4h square. Okay now, this already we learned. The same concept applies for the pair of lines which does not passes through origin. Let this pair of lines does not passes through origin, d1 and d2. Okay now, then the equation is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. Then here also the product of the perpendiculars is same concept. Alpha comma beta substitute on the left hand side of the equation. So that is given by a alpha square plus 2h alpha beta plus b beta square plus 2g alpha plus 2f beta plus c upon under square root of a minus b whole square plus 4h square. So here denominators are same. Numerator is also almost same. The only thing is substituting alpha comma beta value in the left hand side part of the equation. Here also substituting alpha comma beta value in the left hand side of the equation of the general form. Okay, na? Both are same. So in the short form, you can remember this equation as so this is modulus of h11 upon root of a minus b whole square plus 4h square. H11 means alpha, substitute alpha comma beta. So this also you can write down modulus of SS1 by root of a minus b whole square plus 4h square. Here the modulus means what? The modulus means we are taking the product as always a positive quantity. Okay, now product means what? The perpendicular distance, it is a positive quantity. D2 is also a positive quantity. Therefore, D1 and D2 also should be a positive quantity. That's why well in advance we put the modulus. So in the denominator also we have to take only the positive square root. Okay, now I hope that you understand this concept. So like that, if you comparatively study the concepts, so for the formulas which are passing through the origin, pair of lines passing through origin, and the pair of lines which does not passes through the origin, if you comparatively study this, you can easily grasp the concepts. Okay, na? So I hope that you enjoyed today's class with some more topics. Tomorrow's class I will stand before you. So until then, all the best.